I'm starting right now. Quick revision. So for the derivative, the most important things, what are they? So first of all, we have the definition of the derivative by using the limit. F prime of x is equal to limit as h approaches 0, f of x plus h minus f of x divided by h. This is called derivative, okay? F prime of x, when we use the limit definition, this is the definition of that. So if we have f prime at a, it means that limit as h approaches 0, f at a plus h minus f at a divided by h. And in the lesson, we have talked about why or how h approaches 0, this will be limit. I have explained everything, but so I don't want to do it one more time here. But what could it be one question? What could it be one question? It could be asked that find the derivative of f of x equals x by using limit definition. So what will be answer of this question? It is this: f prime of x is equal to limit as h approaches 0, f of x plus h minus f of x divided by h. So it will be limit as h approaches 0. Now, you can easily tell me that in function f, if I substitute x plus h, you know f is here, what will be fx plus h directly is equal to x plus h. This is the f of x plus h minus f of x. So f of x is given as x divided by h, and then limit as h approaches 0. The numerator will be x plus h minus x, this. And then this will be limit as h approaches 0. If I simplify, it will be h over h. So after this step, I can say that this is equal to limit as h equals 0, 1, y1. It's clear that h and h, the common thing, so I can simplify. And we know from the first term, limit of any constant number, the number itself. So the answer of the question is f prime of x is equal to 1. That's it. This is finished. If I ask, what is the f prime at 5? Just you will put instead of x 5, and you will do the same process and you will get the answer. This is the first thing we should know. The second thing, which is very important, it's a crucial thing, is this: slope of f of x at x equals a is given by slope of the tangent line is given by f prime at a. So if you want to write the equation of tangent line to the given function at a given point, the slope is equal to first derivative at that point. So how could it be one example in quiz or in exam? How could it be one example? This: find the equation of tangent line to the function f of x equals x squared plus 4 at x equals 1. So what will be answer of this question? So we have to know that to write the equation of tangent line, the equation of tangent line is y minus f prime at x0 is equal to, let us correct this, not f prime, let me correct this, y minus f at x0 is equal to f prime at x0 times x minus x0. This is the equation of the tangent line. The reason is so simple. The region is so simple. What was the equation of any line? It is y minus y1 is equal to slope times x minus x1. So this is slope. Slope means the first derivative at x0. By the way, what is x0 in the given question? It is when it says at that point is, we can say that x0 is equal to 1. And then we can solve the question. How we can solve the question? To solve the question, what I need fx0, which is f at 1. So the function f it's given here, which is x squared plus 4. So it will be 1 squared plus 4, which will be 5. And in the question, in the solution, I need even f prime x0. So I need f prime of x. So by using the rules x squared derivative plus 4 derivative, and the rules says that it is 2x plus 0, which is 2x. Now, when I know that f prime of x is 2x, what will be f prime at 1? It will be 2 times 1, which is equal to 2. Now everything is ready for me. I can write my equation of tangent line. So it is equal to y minus f at x0, which means 5, times slope, which is here 2, and x minus x0, which is 1. And then if I arrange this, y is equal to 2x minus 2 plus 5. So one more step, y is 2x plus 3. That's it. This is the equation of the tangent line, equation of tangent line to x squared plus 4 at x equals 1. So imagine graphically, if this is my function x squared plus 4, now when x is 1, here, let's say, so on this graph, I am drawing a tangent line. So equation of this tangent line is 2x plus 3, and our original function is x squared plus 4. That's it, we did it. Okay, so this will be one of the quiz or one of the exam question in the upcoming weeks. Till here, do you have any question, dear students? So we are making revision, don't forget, we already know this, we have studied this before. Now, let me continue now. For the derivative, there are some crucial rules. The rules for the derivative, So of course, I am not going to write all the rules. The most important rules I will write. So the first thing is we should know f prime of x or y prime or d dxy or df dx. These are all the same things. These are all same, okay? And let me start the rules. If I say f of x is equal to only x, so its derivative is f prime of x is 1. So derivative of x is equal 1. So simply let me write here, derivative of x is equal 1. When we use this prime, it means that it is derivative. Okay, this is not x to the power of 1. No, it is x prime, we may pronounce, we may read, which is the derivative of the function f of x. Now the second thing, f of x is equal to x squared. If you have, its derivative is 2x. So these are the functions we see so much. F of x is equal to x cubed. Its derivative is f prime of x is equal to 3x squared. But now, if you realize that there is one rule, when you have x to the power of 3, 3 comes in front and we decrease the power of x by 1, 3 minus 1. When the power is 2, 2 comes in front and we decrease the 2 minus 1, 1. When the power is 1, 1 comes in front and left x to the power of 1 minus 1. So x to the power of 1 minus 1 means x to the power of 0, and x to the power of 0 is the exponential number. You know that it is 1. So if we generalize this, we have one important rule, which is called the power rule. Even we can say, let me use by using x, this is better right now. X to the power of anything derivative, x to the power of n derivative is n comes as a multiple, n times I mean, x to the power of n minus 1. This is our rule. So if I say what will be x to the power of 7 derivative, the answer is very simple. 7 times x to the power of 7 minus 1. So it means that 7x to the power of 6. N is the power. We take the power in front of the x, so 7 times, and we decrease the power by 1. So similarly, if you have f of x is 1 over x, it means that x to the power of negative 1, so f prime of this, it will be negative 1 over x squared. The reason is same. If I prove this, x to the power of negative 1 derivative is equal to negative 1 comes in front and we decrease the power by 1. So negative 1 times x to the power of negative 2, which is negative 1 over x squared. So you can memorize this. So often we see this for that reason. So often we see this. So often we see this. So you, whenever you see, so you can write directly, this is 1, this is 2x, this is negative 1 over x squared, or just use this power rule. The power rule is take the power in front of the question times x to the power of n minus 1. And then we have studied something as a rule, derivative of any constant number is equal to 0. C is here, C is any real number. So, for example, f of x is 2. So, f prime of x is equal to 0. F of x is root 7, for example. So, f prime of x is equal to 0. So, whenever you have any constant number, derivative is 0. Why? It's so simple graphically if you think, get the logic. F of x is 2 means y is equal to 2 line. What is the derivative? Derivative of a function means slope. What is slope means? Delta y over delta x. Change in y divided by change in x. So whenever you take any 2 points, for example, this is 2 and this is, let's say, 7. So what is delta y? Delta y is 7 minus 2, which is 5. What is delta x? Delta y is, when x is 7, y is 2. When x is 2, y is still 2. 2 minus 2 is 0. But what about delta x? 7 minus 2, which is 5. So delta y over delta x will be 0 over 5. So what is 0 over 5? 0 over 5 is 0. So whenever you have any constant number, since the y values are always the same point, same constant, the x values are changing, but it's not important why. When the numerator is 0, the same y, when it will be y2 minus y1 refers to the same y value, which is 0, their subtraction, their difference. So 0 over any number itself, always it will be 0. For that reason, we say that the derivative of any constant number is 0. So what we have studied, we said also when you have f of x plus g of x, its derivative, this is equal to derivative of the first function plus derivative of the second function. Or if you have f of x minus g of x, when you have the difference, so derivative of the differences, so we take separately their derivative of differences. Now, this is the very important rule. And whenever we have k times f of x, its derivative, so we take the k out and we take the what is left, its derivative. For example, if you have 5x squared derivative, here the k is 5, By the way, what is k? K is any real number, any real number. Okay, so take the k out. So what is left? Take its derivative. And we know that derivative of x squared is 2x. So result is directly 10x. Okay, so these are very important tools, very important properties to take the derivative or the answer of the derivative. But whenever we have, so the most important thing now starting, guys, whenever we have f of x times g of x derivative, here be careful, this is not equal to derivative of first times derivative of second. No, it is not. We have one rule. We call this rule is derivative of product or product rule. Derivative of product of functions, which is two functions actually. This is now f of x times g of x derivative is equal to, be careful now, okay, focus on here, derivative of the first function times second function itself plus derivative of the second function times the first function itself. So if I say that, if I say that, if I say that u is equal to f of x and v is equal to g of x, okay, what will be now u times v derivative? I mean f of x times g of x, same thing, just this is u prime times v plus v prime times u. U prime v prime u. So it's better to memorize like this. Derivative of product of any two function is equal to u prime v prime u. It means that derivative of the first function times second plus derivative of the second function times the first one. Okay, and then the other very important thing, derivative of the quotient. What does it mean? F of x divided by g of x derivative is not equal to f prime of x over g prime of x. This is wrong. So what is the rule? The rule is this: f of x divided by g of x derivative is equal to derivative of the first one times the second one itself. So derivative of first one times second one minus, not plus, minus derivative of second one times first one divided by second function to the power of 2. So if I use u is f of x and v is g of x, so u over v derivative is equal to u prime times v minus v prime times u v to the power of 2. So it's better to memorize like this. So derivative of the numerator times the denominator minus derivative of denominator times numerator divided by denominator to the power of 2. So let me make example for this. By the way, how many minutes we have? Do we have enough minutes? Enough time, I mean? Or let's make it, I think we passed the break time also. Let me give
No, we
you
have 3 minutes, sir.
let me give you 10 minutes break, guys. Okay, 10 minutes break. Let me give you right now. Now 12:37. 12:47. I will continue revision and then I will start the next lesson. Okay, I will continue. 10 minutes break right now. So let's go on some examples. Let's do it quickly. Still, I am telling to you that first are we started revision and the formulas, rules, what we have studied. Now, let's say one example. Let me say f of x is equal to, let me tell you that cube root of 2x times x squared plus 5x plus 10. So the question is, find f prime at, let's say, 1. What does it mean? It means that firstly we should find derivative, which is first prime of x, and then we should substitute instead of x in the result number 1. So to do this, I cannot do that the derivative of the first one times derivative of the second one. No. What can I do? I can call the first function is u, the second function is v, and then remember that derivative of the product of two functions is equal to that derivative of the first one times the second one plus derivative of the second one times the first one. It means that I will have cube root of 2x derivative times the second function itself, copy paste, and then plus the second function derivative times the first function itself. Now this should be evaluated. This should be done. So how can I do this? First of all, I can say that cube root of 2x could be written as 2x to the power of 1 over 3. And it could be written as 2 to the power of 1 over 3 times x to the power of 1 over 3. So when I need derivative of 2x to the power of 1 over 3, it means that this is 2 1/3 times x to 1/3 derivative. And then remember the properties that we said that this is any real number like k multiplied by a function. So we take that real number out of parentheses. So what is left? We take its derivative, and this will be 2 to the power of 1 over 3. It's outside times. Power rule says that take the power and decrease the power by 1. So it will be 2 1/3 times 1/3 times x to the power of negative 2 over 3. And then it will be finally cubic root of 2. This means cubic root of 2 times 1 over 3 times 1 over, when it goes to the denominator, as you know that it is cubic root of x squared. Okay? We know this how to write. Now, let's go back now solution then. The derivative of the first one we have just calculated, cube root of 2 times 1 over 3 times 1 over cube root of x squared times the second function itself plus derivative of the second function. So derivative of x squared, which is 2x, derivative of 5x, which is 5, and derivative of 10, it's a real number, so its derivative is always 0, times cubic root of 2x. So we can order this, we can equalize the denominator, we can do lots of things, but forget about them. Just the question is, what is the derivative at function 1 when x is 1? So I can put it f prime at 1 is equal to, since this is now f prime of x, this is now f prime of x. In this function, when I see x, I can put 1. So cubic root of 2 times 1 over 3 times 1 over cube root of 1 square times 1 square plus 5 times 1 plus 10 plus 2 times 1 plus 5, 2 times 1 plus 5 times cubic root of 2 times 1. So if I rearrange this, so let me clean the right side, or let me clean one with this part. Let me clean this part. The final result will be cubic root of 2 over 3, cubic root of 2, cubic root of 2 over 3. And you know 1 square is 1, cubic root of 1, so this is directly 1. 1 square and 5 times 1, 5. 5 and 1, 6. 6 plus 10, 16 times 16. And then plus 2 times 1, 2, 2 plus 5, 7, times cubic root of 2. And one more step, if I do this cubic root of 2 common parenthesis, 16 over 3 plus 7, and one more step, cubic root of 2 times 7, 3, 21, 31, 37 divided by 3. So if yeah, I can leave like this, or 37 divided by 3 times cube root of 2. This is now final answer, okay? So first derivative at 1 is equal to 37 over 3 times cubic root of 2. Now, what we did here, we used the derivative rule for the quotient when we have the division of two things. So derivative of numerator times denominator minus derivative of denominator times numerator divided by denominator to the power of 2. No, I think we didn't use this. It was the division, but we don't have division. We have just product, right? We use the u times 3, which is first one derivative times second one plus second one derivative times the first one. So one more time, u times v derivative is u prime v plus v prime u we used, and we got the result 37 over 3 cubic root of 2. That's it. Now let's me solve one more question for the division. So let me choose the simple one, not so complicated. F of x is equal to, let's say, x squared plus 2x plus 5 divided by x cubed plus 2. Okay, so the question is f prime at 1 or 2 or 3 or 0, whatever. Okay, this is the question. So to solve this question, if I call that u is equal to x squared plus 2x plus 5 and v is equal to x cubed plus 2, my question is actually what is the u over v derivatives? This is the question. And then in that result, I will substitute instead of x1. So I know that u over v derivative is u prime times v plus, minus, not plus, don't make this mistake, u prime times v minus v prime times u all over denominator to the power of 2. So in my question, what is u prime? X squared plus 2x plus 5 derivative is 2x plus 2. What about v prime? 3x squared plus 0. Even here 0 I can say. So 2x plus 2 and here 3x squared. And then the result will be then u prime, which is 2x plus 2 times v, which is x cubed plus 2, minus v prime, which is 3x squared, times u, which is x squared plus 2x plus 5, all divided by denominator to the power of 2, x cubed plus 2 to the power of 2. Now, guys, this is now f prime of x with it. Now the
Sir, I have a
question
question.
is, what is f prime at 1? So how can I solve this? Whenever I see x here, I will put 1. So let me change the color. So it will be 2 times 1 plus 2 times 1 cubed plus 2 minus 3 times 1 squared times 1 squared uh, plus 2 times 1 plus 5 divided by 1 cube plus 2 squared. So if I write, what will be f prime at 1 equals 2, 1, 2, 2 plus 2, 4. 4 times 1 and 2, 3. 4 times 3, 12 minus 2, 1, 2, 2 plus 5, 7 plus 1, 8. 8 times 3, 24, divided by 1 and 2, 3, 3 to the power of 2, 9. So result is negative 12 over 9, and one more step, negative 4 over 3. So this is our final result. So whenever we have division, numerator derivative times denominator minus denominator derivative times numerator divided by all denominator to the power of 2. When we use the formula, we are getting the final result. And then last week, we also have studied higher order derivative. What does it mean, higher order derivative? When you have the function f of x, its first derivative is f prime of x. We call this is first derivative. Now, when we have derivative of the first derivative, it will be f double prime of x, and we say second derivative, and so on. If we have derivative of second derivative, we will have third derivative. So we will call third derivative, okay? And so on. So these are called higher order derivatives. Higher order derivatives. Now, let me make one example for the higher order derivatives. So y is equal to, let's say, x to the power of 5. Now, find all the derivatives of y. So first derivative, by using the power rule, 5 times x to the power of 5 minus 1, which is 5 times x to the power of 4. Now second derivative is derivative of the first derivative, which is 5 times x to 4 derivative. So 5 is a k, which is a real number, take out. So the remaining one, x to 4 derivative. So by using the power rule, power which is 4 comes in front, and we decrease by 1, so it will be 20x to 3. Right now, this is second derivative. So what is the third derivative? Third derivative is derivative of the second derivative. It means that derivative of 20x cubed. So k is real number, take it out. What is left? It's derivative. So power rule, take the 3 in front, x to 3 minus 1, finally 6x squared. And so on. If we say the fourth derivative, so this is equal to third derivative, which is 60x squared derivative, which is 60 times x squared derivative. So 60 times 2 times x to 2 minus 1, 120x. Now, fifth derivative. Fifth derivative is derivative of the fourth derivative. So 120x derivative. So it will be 120 is real number, take out x derivative. So y fifth is equal to 120. Y x derivative is 1. And now derivative of the sixth derivative. Sixth derivative is, so we can use parentheses like that. Now sixth derivative is derivative of the fifth derivative, which is 120 derivative. Derivative of any real number is 0. What about seventh derivative? Seventh derivative is derivative of the sixth one. Since sixth one is 0, 0 derivative 0. Eighth derivative of 7. So 7 derivative 0, that means derivative of 0, 0. So I mean all the derivatives will be 0. So no need to continue. It's over. It's finished. So first derivative is 5x. Second derivative is, first derivative is 5x to the power of 4. Second derivative is 20x cubed. Third derivative is 60x squared. Fourth derivative is 120x. Fifth derivative is 120. And the sixth derivative is 0. And 7, 8, 9, all other derivatives are 0. So this is called higher order derivatives. Chat screen, there is something. Let me look. No problem. Now, it's okay, Human, there's no problem. And the last thing we have studied last hour, it was implicit differentiation. First of all, we should know that what is implicit function. Implicit function is a function that in this form, f(x, y) is equal to c. Be careful till now, what you have studied, f of x and y is equal to f of x, we said. Okay, it was, for example, 2x squared plus 4x plus 5. So when you look at here, this is now x is here independent variable, and y is here dependent variable. What does it mean? When x is changing, f of x, which is y, automatically is changing based on x. If you increase x, y is increasing. If you decrease x, y is decreasing. But now this is different. This is different. Implicit differentiation for implicit function, and implicit function, for example, x squared plus y squared is equal to c, which means y squared is equal to c minus x squared, which means y is equal to plus minus c minus x squared, which means that y is negative root and y is positive root. Let me give you one example. Let me give you one example. Whenever you have x squared plus y squared is equal to 16, you know that what is this? What is the graph of this equation? If you remember the circles, x minus x0 squared plus y minus y0 squared is equal to radius squared, where center is x0, y0. So this function is center is 0, comma 0, and radius is 4. This is the equation of a circle, which means center is at the origin here, and radius is 4. So we can say that these are all 4 units. Okay, so this is right now, this is a circle. So x squared plus y squared 16 is this one. X squared plus y squared 16 whole circle. But if you remember the vertical line test, what was it? When you draw the vertical lines, if it cuts more than 1 point, this is not a function. This is not a function, we said before. Yeah, in calculus, AP calculus, we call this kind of things, yes, it's not a function, but we call them implicit function. Implicit function. So x and y depends on each other directly. And I can say this one. One part of the function, which is here, is y is equal to positive root 16 minus x squared, and the other part of the function, which is here under the x-axis, y is equal to negative 16 minus x squared. Right now, separately, vertical line test, yes, this is a function. Vertical line test, yes, this is a function. Separately, these are being a function, but together it's being another function. So we call these cases simply, I'm just simplifying the thing. So it's a huge topic, difficult topic. Just I'm trying to explain how simple to you. So when we divide or separate this function two parts, one part is being a function, another part is also being a function, and we call that this is implicit function. Now, what are we going to do? I have given you one formula last lesson. Whenever you have fx comma y is equal to c, implicit derivative is equal to this one, minus the derivative of the given function with respect to x and derivative of the given function with respect to y. Example, what does it mean? When I have x squared plus y squared is equal to 16, if I ask you that what is f prime x comma y, the answer of the question is this, negative. So derivative of the given function with respect to x, what does it mean? Here, be careful. This is actually partial differentiation. We will study later if we will have a time, the fourth term at the end of the year. It means that in your function, in your equation, whatever you see different than x, you may regard as it's a real number, like 2, like 3, like 4. It's a real number. Okay, so in my question, derivative of x squared, it's 2x. The derivative of y squared, right now y is like a number. Number derivative is 0. And then and then 16 derivative is also 0. I am not writing one more time. So x squared plus y squared minus 16, even I can write like this, okay, is 0. Now, if c is 0, I mean, if c is 0, now derivative of x squared is 2x, derivative of negative y squared is 0, negative of 16 is 0. Now, denominator derivative with respect to y. It means that whatever you have different than y, right now it's like a real number. X squared right now like a real number. So real number derivative is 0, y squared derivative is 2y, and the negative 16 derivative is 0. Final result is negative 2x over 2y, which is negative x over y. This is now derivative of implicit function. Okay? Any question for this? Let me write one more question to understand better. So let me write this. 2xy minus x squared plus y squared is equal to 0. What is the fxy derivative? Better to put the derivative symbol. Yeah, derivative symbol after f. Yeah. So what will be? The answer is negative derivative with respect to x divided by derivative with respect to y, negative or minus. Right now, when I look at here, 2 is a real number. Now, since I am taking derivative with respect to x, y is a real number also. So, if I have, for example, 5x derivative, what do I do? 5 times x derivative I do. So, same thing. I will do 2y times x derivative. And then this is directly number. So if you have just number derivative, what is that? It is 0. So this is number I said, but it is for denominator. We are in numerator. So this is fx, derivative with respect to x. What is the derivative of x squared? The derivative of x squared is 2 times x. I know this. Now y squared, like a number, since there is no x here, it will be 0. Now derivative with respect to y. So 2 is a number, x is a number, y is a function. That means that 2x times y derivative minus x squared. It's a real number, so 0 plus y squared derivative. So let me copy y squared derivative. And then numerator will be 2y times, what is the derivative of x? It is 1 minus 2x. What is the derivative of y? Derivative of y, it's y prime, but derivative of y with respect to y, which is 1, where is eraser? So it is here, it's 1 minus 2 y squared derivative, so it is now 2y prime. It will be our solution. So negative 2y minus 2x divided by 2x minus 2. By the way, y prime is 1, so no need to write this one. Now, if you divide by 2, since everything is common, y minus x divided by x minus y. Y minus x, x minus y, can I write like this? Yes, I can. That means result is negative 1, which is positive 1. Derivative of this function is positive 1. I mean, this one and this one, you can simplify. It will be negative 1. Negative and negative 1 will be positive 1. Okay, that's it. Now,